Good morning. Today we'll discuss about index objects, reindex, drop entry, and selecting entries. So, in the previous discussion itself, we discussed about what is indexing. So, indexing is a fundamental operation for accessing and manipulating data efficiently. It involves assigning unique identifiers or labels to data elements, allowing for rapid retrieval and modification. So in the previous video called as series and data frames, where we have a set of data elements and how to access these data elements, we have it is started with 0, 1, 2 and all. So that is nothing but the indexes. Only by indexes we can able to modify, or you can able to retrieve the data in an easier manner. So these are called as index objects. So pandas, a powerful Python library for data manipulation, extensively utilizes index objects, and these are immutable sequences. So that means you cannot change it. Okay. So that the next is characteristics of index objects. Immutability. So once created, the index cannot be modified. And then the alignment. Index objects are used to align data structures like series and data frames, where in the series data frames video we discussed in detail about the alignment concepts. And flexibility, it also, like in index, even we retrieve the data by using ILOC or LOC. So that means you can able to use any kind of indexing, like it can be including integer based data and custom indices as well. So, like the importance of indexing in data science. Efficient indexing is crucial for large data sets as it significantly impacts performance. So, these are the four main things of indexing. So, because of using indexing, there will be a faster data retrieval. Well indexed data can be accessed quickly. That means if you have the index, each and every data retrieval will be more faster when compared to data without indexes. So normally indexing is a one good feature in pandas. Then optimized queries. Indexing supports complex queries and aggregations. In the data series and in the series and data frame, we discussed about how we can able to use the aggregation concepts. Data alignment. Aligning data based on indices ensures accurate calculations and operations. Finally, data manipulation. For in order to modify the data, or in order to filter the data based on set of conditions, we'll go for indexing. First, we'll be selecting the data by using indexes, and then we apply some kind of aggregation or any kind of manipulation. You can able to do it on the data. So let's see one by one. First, how to create an index. In order to create index, first we have to create a data frame. Okay. So in order to create data frame, first you have to import the library called as pandas as PD. So the alias as PD. Now you have the data. So the data is given in a dictionary format. Now in order to print the data, normally we go for PD, the alias name dot data frame, and then we give the data, and what are the index values we want to give, we can give with the index parameter. So like we have name alias Bob Charlie, so alias Bob Charlie will be there, and age is 25, 30, 35. So these are the values, these are the two columns that we have. Now we want to set an index A, B, C. Now it is a custom index, like instead of normally a default index will be 0, 1, 2. Now we are going to customize it. Now we are going to add a separate column, or the index nothing but ABC. So next is reindexing. Reindexing is nothing but process of creating a new data frame or series with a different index. That is what reindexing is. In order to use this reindexing method, reindexing concept, we go for the reindex method. So reindex method is used for reindexing. Applications of reindexing. So these are the three applications of reindexing. Aligning the data frames for operations by ensuring that data frames have the same indices before performing calculations or merging. Only then the operation can be performed. For example, let's say I have I have two data frames and I want to merge these two data frames. How it can be merged? Like in the first data frame, if I have zeroth index, and in the second data frame, I have zeroth index. These two, it is going to check in both the data frames that whether there is a zero index. If that is the case, in that time only it is going to merge it. And filling missing data. So using fill value or interpolation methods will be used to handle missing values. And you can even change the index order as well by in order to rearrange the order of rows or columns. So now we'll discuss about reindexing. In order to use reindexing, first as we said, like create a data frame with an index called as ABC. Now we are going to create a new index, that is reindex it. So new index is nothing but ABDE. Now already whatever data we have, right? So it is going to compare, check, see here, the allies Bob and Charlie was the data in the earlier data frame, and age we had like 20, 30, 35. Now we had a new index called as ABDE. So now ABC is there, but ABD is there. ABDE is the new index. So now we are going to create a reindexing. So you are going to reindex it. So in that case, it is already we have A, B, but we don't have C. So what happens is the new index A, B, D will be created and checks for the data, but A, B alone is found in the data and D is not there. So it is going to insert those values with NaN. So next is drop entry. So drop entry, as the name implies, dropping the entries. So dropping entries in data science refers to removing specific rows or columns from a data set. Like if a particular feature is not helpful, feature or a particular column is not helpful in predicting, then we go for removing that particular column or dropping that particular entry, either a row or by a column. So this is a common operation in data cleaning and pre-processing to handle missing values, outliers, or irrelevant information. So while before dropping that particular row or column, we have to check in three major things. One is missing values. If we have missing values, we go for imputation or other techniques before dropping rows or columns. Then we go for outliers. Carefully analyze outliers before removing them. So whenever we have outliers, before removing, we have to check whether it contains any valuable information or not. Then the data loss. Dropping entries can lead to data loss, so proceed with the caution. In this case, see here, like we have created a data frame and this DF is our data frame. And now what we are going to do is, in this data frame, in the previous case, we had a column called as age. Now, if we wanted to remove this particular column, we go for drop entry. So drop method. So apply this drop method. So what I'm going to do, age is the column which I'm going to check, which I'm going to drop it, remove it by, and then you're going to set the axis. Axis equal to column. So column wise dropping will be happening. So df dot drop and the new data frame will be therein. So the modified data, right? So the age column is removed and only the name column will be stored in the new data frame, and we are displaying the new data frame. And then selecting entries. Now as said, like indexing is particularly used for selecting a particular row or selecting a particular column or some subsets of data from a data frame. You can able to select by label, you can select by position or select by condition. So here selecting by column, as I said, like in order to create a data frame, pandas, import pandas, then create the data. So here it's a dictionary, it's in dictionary format. Now name, and we have Alice, Bob, Charlie, and age is 25, 30, 35, and city is New York, Los Angeles, Chicago. Now we have created the data frame. So the data frame is created and it will be like this. Now what we want to do is, so in the real time data, it is not like only 3 rows or 5 columns like that. You will be handling a huge amount of data. In that case, I want to select a particular column. I want to see what are the values that are there, what type of values are there in the particular field, means you can go for selecting a specific column by using indexing. So in that case, we go for LOC attribute, and this, so it is going to select all the rows and then the column. So the first one is row, the second one is column. I'm going to select a specific column, that is nothing but the age column. And even you can able to select by position as well. In the previous case, we selected by label. The label is nothing but age. Now we are going to select by position. So by position, in the sense, you are going to select a particular row or maybe a particular column. So now here in this case, what we are going to do is ILOC of 1. In that case, the first row alone gets selected and gets displayed. Already the data we have created the same, like the previous example, the created data frame is this one. Now we are going to select a particular row. So here we are going to select a particular row only by using ILOC of 1. If I want to select a particular column, you are going to use like colon, comma, the particular value, whichever row you wanted, whichever column you wanted to. Then select by condition. Even you can able to, apart from label or apart from position, we can also select the data by condition. So here, in order to create a data frame, as you all know that, import the library and then the data frame is created. Now what we are going to do is, in this data, we are going to select a particular data. Like for example, I want to select a particular row where age is greater than 30. So in the, it is going to check the entire data frame, and wherever age is greater than 30, it is going to check that, it is going to retrieve that data. So for what we are going to do, df of age, so that means it is going to select in the data frame particular age in that age column, and then it is going to check again 30 where it is greater than 30. That, so df of age greater than 30 is true or false. Again each and every column, and again you're going to apply a data frames where you are going to retrieve the data. That's all about indexing. Thank you.